Hi everyone, I found this stud and metal and voltage finder on the flea market and I brought it home to test it out, and it turns out that it works kind of, but there are some issues with it that I want to address in today's video. Namely, whenever I turn the stud finder to test out metal and voltage, it just beeps as if there's something always present. So probably something is messing up with the circuit inside. So there's no manufacturer marking on the device, so I wasn't able to find it online. If anyone has an idea what this device is, I tried searching for this number, but I didn't find anything for it. So it's kind of an exploration video for today. Now, there are two screws that hold this device in, so now let's try to remove them and see what's on the inside. This video is sponsored by PCBWay. PCBWay offers custom PCBs, PCB assembly, CNC machining, and 3D printing for really low prices and great quality. I use PCBWay when I need PCBs for my projects, and they always deliver perfect quality PCBs. PCBWay is your one-stop shop for all of your prototyping needs, and you can even get your first order for free. Visit their website on the link below and you will get a $5 coupon to jumpstart your projects and get it professionally manufactured. Okay, so here's the inside of the device. On the back side we have the coils, which seem to be 3 of them. So there's one up here in the front, there's one that goes all the way in the back, and then there's this one with a ferrite in between. And I think that's being used to generate some sort of field, but immediately on the left side of the board I can spot a lot of corrosion. So probably this device was either subjected to some liquid damage, or it was kept in a place that is kind of wet and moist, so maybe that's causing the problem. It seems that it's using several ICs. Let's pop up the board from the holder and let's see what's on the other side. As you saw before, this one is powered from 9 volts, and here we have the board. There's a PEAK microcontroller. It's a PIC 160711, and here we have, what's this one? It's probably an op-amp CD4093BE. What else? Some discrete components, capacitors, resistors. There's a trimmer pot that's probably used for adjustment, and there's another one down here for 6 transistors, the buzzer, and the 2 buttons with the switch and the adjustment potentiometer in the middle. So let's first try and clean this up. I'll use isopropyl alcohol for that, and we'll see if it behaves any different when we turn it on. So let's try that first on the back side. Okay, so I've cleaned the board as much as I could. I even took out the microcontroller and cleaned the pins on the socket there. And we don't have any of that white residue that we had before. So my plan now is to try and turn this on and see if we're gonna get that beep that we had before. I'll just pop it here in the holder. We might not get an accurate reading because of the position, but I just want to see if that beep is gone or not. So this one is in off position. I'll connect the battery, and now let's try and turn it on. We still have that beep. Okay, so next thing that I'm gonna try is to try and reflow some of the joints here. So if you can see here, let's bring that closer. You can see here that not all of the joints were made solid with the soldering, so I suspect that something might have gone bad. Like for example, this wire here doesn't seem to be on very well, so I'll try to reflow some of them and see if that makes any difference. And then if that doesn't make any difference, then we'll start and do some component testing and see how that goes. I think I have addressed all of the joints that I thought that might be problematic, so they are reflowed now. A microscope would have been nice to have, but I don't. So based on my visual inspection, I think that all the joints are good. So let's try again now. Plugging in the battery to see if there is any change to the circuit. We still have the circuit in the same configuration for the metal and voltage, and we still have the same problem. Okay, now let's try and inspect some of the components on the board, and maybe that will give us some indication of what might be happening.
Much later.
Okay, so it's now a few days after the last clip that you saw, and I've done some measurements on the board, I've done some inspection, and basically I've came to the conclusion that that's the best that I can do with the tools that I have. I currently don't own an oscilloscope to monitor some of the frequencies, some of the signals that are generated on the board, so I'll call it a no fix for now, because at some point you got to say no to a project, and I think that this is the stage that I'm currently at. I've tried replacing some of the components that I had replacement for, like this electrolytic capacitor here and these BC547 transistors here, but unfortunately that did not make any change, and so the logical next step would have been to hook up an oscilloscope and probably monitor the signal that the PIC microcontroller generates for the induction for the coil here, and then monitor the signal and then what's coming out of these other coils and sensors. So these two are not coils. Basically, they are just, this one is just like a capacitive touch plate that's probably used for the identification of conductors, and this one is like a big capacitor that's being connected to the board, and it then compares probably the density behind what it measured to identify if there is wood behind the drywall. What else? I've tested all of the components that I could test with the tools that I have, and they all measure good, so there is no open circuit diodes, there are no open circuit or short circuit transistors. Most of the transistors here are the KSP13, but I don't have a replacement to try and replace them, so I'll end the video here. I hope that you were at least able to pick up some of the techniques that I used in order to identify flaws with electronics, and that you can maybe try and follow it out. If you would like, then let me know and I'll post pictures from the board and the underside if you maybe want to reverse engineer the whole thing yourself, or you can just screenshot it from the video and maybe try to suggest a fix that way. If not, then I'll see you all in the next one. Thank you for watching, subscribe, and see you in the next one.